Okay, great. Thank you. So, hello, let me introduce myself. My name is Matt Salvage. I'm the networking manager for sales engineering for Grass Valley in EMEA. I look after the team of pre-sales engineers that look after all of the network design throughout EMEA, both for IP and non-IP broadcast systems.
Hello, everyone. Hi, my name is Rahul Parmeshwaran. I'm a senior manager of technical marketing within Cisco in the business unit that's responsible for the Nexus 9K and NXOS DCNM, and I focus on the media and entertainment vertical.
Okay, great. So together we're going to take you through over the next 20 minutes or so. We're going to talk about how Cisco and Grass Valley are coming together and providing lots of solutions. Now, there are a large number of areas that are covered by our solutions, and this can range from producing shows either in a studio or in outside broadcast locations. It can be making use of remote workflows to monitor and create content, and then finally to playing out the TV channels. In this session today, we're going to be concentrating on the IP workflows that can be used to facilitate many of those use cases. So many broadcasters have been making the transition from SDI to IP over the last few years, although it does take time, especially when there's an existing facility. However, more and more, we're seeing that new installations, whether that's OB vehicles, new broadcast facilities, or expansions to existing facilities, are moving forward with IP-based solutions. And historically, it generally takes around 15 years for a disruptive technology to achieve full adoption. There are many historic examples of this, but the image here shows a good example with the transition from horse-drawn transport to the use of motor vehicles, with one car being visible in a sea of horses in 1900, and there only being a single horse visible just 13 years later. Assuming this pattern that we've seen many times before holds true for IP in the broadcast domain, we're now around halfway through completing the transition. If we take a look at the 2020 Big Broadcast Survey from Devoncroft, we can see that IP networking and content delivery has retained its position within the top two most commercial importance to broadcasters, having been in the top two for each survey since 2017. Whilst it's clearly important in its own right, it also can be an enabler in many cases for other important concerns seen here, such as remote production, virtualization, or as part of the migration of the facility to support UHD workflows. And when we look at the IABM special report, which was released last September, we now see that 30% of broadcasting companies have already adopted or transitioned to IP in some form. 56% of the companies surveyed stated that they're likely to deploy IP solutions in the future, and there were only 13% of companies saying that they're really now unlikely to transition to IP. So the upgrade from SDI to IP, it remains a strategic area of focus for many broadcasters, and it's therefore one of the most important priorities in technology roadmaps. Now, there are a number of concerns which we often hear about when we're discussing the move to IP. There's the complexity of the solution, both in terms of commissioning, maintaining, and operating the system being of high importance. Whilst there are always going to be some challenges and many different things to consider, we've been concentrating really strongly on this area. It's been possible to create IP solutions for a number of years, but the more recent developments in products, such as GB Orbit, have been specifically designed in order to reduce this complexity and make IP easy. In the early days of IP solutions, compatibility was always a concern, both for the format of the stream itself and the control. Now, while the discussions around stream compatibility are largely solved, with a pretty universal adoption of SMPTE 2022-6, followed by SMPTE 2110, the standards related to control and monitoring are still continuing to mature. So whilst the NMOS standards themselves are continuing to grow, we are strong supporters for common non-proprietary standards and have already included NMOS ISO 4 and ISO 5 in the vast majority of our IP-enabled products available today. Cost is another concern, but we're going to look at that a bit more on the next slide. Of course, there are also a number of really good reasons why IP solutions are being considered. Whereas traditionally, the movement from HD SDI to 3 gig SDI, or from 3 gig SDI to 12 gig SDI, would have required a replacement of the core infrastructure. In an IP solution, it's simply a question of more bandwidth being used. Multiple different signal types, traditionally each requiring different infrastructure and having separate connector types, can be transported and switched in the same core. So now large numbers of signals can be transported in the same fiber. So in a real-world example, a 1080p signal running at 5994 kilohertz, when that's encapsulated as a 2110 signal, it requires just over 2.6 gigabits of bandwidth. So if we're looking at an SDI cable, we know that each SDI cable would allow one signal to travel in one direction. When we're looking at IP, a single 100 gig fiber would allow up to 36 signals in each direction. So in other words, one fiber could replace 72 coax cables in that example. IP also lends itself really well to allowing distributed systems with resource sharing. So instead of building a linear signal path with devices designated for a specific usage, it's instead possible to consider every connected device as a resource in the system. Where we may have traditionally had a multi-viewer output directly connected to a specific monitor in a specific room, we can now think of having a bank of centralized multi-viewers, which are outputting streams that can be subscribed to in any room. This is, of course, not limited to multi-viewers, but can be considered for all aspects of broadcast, allowing broadcasters to make a better shared usage of resources to increase the utilization rate of equipment. So whether that's dedicated hardware or it's virtualized software. The other key advantage of moving to IP, and doing so in an entirely non-proprietary way using common standards, is that you're able to use commercial off-the-shelf hardware. So in this way, we're not limiting ourselves to only use equipment designed specifically for the broadcast market, but can use the same equipment being used elsewhere in other sectors, taking advantage of the economies of scale and the technology R&D growth that provides. So if we look at the costs a little bit more closely, you can see on the two graphs an indication of typical costs between traditional baseband systems using SDI routers at the core and those built using IP network switches. The yellow line is representing the normalized cost of a system built around a baseband router. The red line is showing the comparative costs when all of the endpoints remain as the same devices with SDI connectivity, and we're just adding IP gateways to connect between SDI and IP to connect into a centralized IP routing core. The green line is showing the comparative costs when all of the edge devices have direct IP connectivity and are directly connected to the IP fabric. So whilst many systems will have a mixture somewhere in the middle, we can see that as a general rule of thumb, small systems are still today typically more cost effective in initial costs for SDI. Larger systems are more cost effective in IP. But the space where that cutoff is coming down smaller and smaller. So the cutoff is around a 256 square 3 gig size of system. So we can also see in the bottom graph that the difference in cost between IP and baseband solutions is smaller when we compare systems that would have included hybrid audio shuffling than those that are video only. Now these graphs are only representing the core routing hardware, and they don't include some other costs for control systems and so on. But we can see, even at smaller sizes, when the initial costs are likely to be higher for an IP solution, it may still make sense to proceed with IP. For example, a baseband router sized at 128 by 128. With that, it just physically wouldn't be possible if the system were to expand to allow a 129 input without replacing and rewiring the entire system. Whereas in an IP world, this would just be an incremental change with an expansion of the network. Now, in order to unlock the real benefits of moving to IP, there are a number of key points that are required and requested by the media industry. Easy scalability. So this is about enabling more revenue streams, adding more services, using distributed resources. flexible utilization, allowing for a simple and flexible deployment and management of the system resources. Dynamic, agile methods for changing functionality as the business needs change, allowing a flexible scaling up or scaling down of the system. Software-defined solutions, allowing the use of generic hardware platforms and commercial off-the-shelf equipment. And pay-as-you-go models, often also including the ability to flexibly switch certain parts of the system on and off as and when they're needed. And Grass Valley IP solutions are designed from the ground up specifically to target both today's and with an eye to these future industry needs. The Grass Valley Dynamic IP Blueprint is designed completely in keeping with these overall requirements. Grass Valley is committed to allowing customers to build systems which are easily scalable, and they build on an open architecture in keeping with the JT&M testing plan. GV Orbit allows for dynamic orchestration with devices added to the network being automatically discovered and available to the control system. So once discovered, these can then be dynamically managed, easily added to control surfaces as sources or destinations that are available to be controlled by operators in a really familiar way. So that operators don't need to be aware whether they are routing SDI, routing IP, or they have a mixture of those signals. Based on the requested source to destination routing, GV Orbit will command the relevant edge devices to join the required streams. And then we'll communicate with the Cisco IP fabric via DCNM to ensure that the flows are stitched successfully, as well as determining the route which they took. So it's possible to build these systems as a single monolithic switch or as large leaf and spine networks. But it's also crucially possible to start with a small system and gradually scale up as the need arises. So with a full portfolio of equipment available, offering direct IP connectivity of all Grass Valley devices for complete glass-to-glass broadcast workflow using open standards, the solutions are available today to build entire systems which can start small, they can start local, and they can expand into large or distributed remote systems. One example of how IP is enabling these workflows is when it's used for remote production or for other truly distributed systems. The signals being generated at remote sites, they can be transported as IP to a central location. Now that could be containing dedicated broadcast hardware, or it could connect into AMP, it's the Grass Valley Agile Media Processing Platform, in either a public or a private cloud. So in this way, geographically diverse sites can contribute into a single cloud core with access to a shared pool of resources that can be configured and controlled by geographically distributed operators for global distribution. This cloud-centric workflow allows for business agility. It allows the use of pay-per-use OpEx models and other new economic models. Once the signals are available within AMP, the operational flexibility to spin up and spin down services as needed unlocks the power of virtualization. Now, I'm going to hand over to Rahul here, who's going to talk about the advantages and practicalities of using a Cisco routing fabric.
Thank you so much, Matt. So essentially, can you just mute your phone? Right, thank you. So as Matt pointed out, right, the benefits of moving into IP is humongous, and that's the trend that we're seeing across our customers around the world. Now, for those of you all who may not be familiar with Cisco's offering, at a very high level, we have Cisco's IP Fabric for Media, and it comprises of two solutions, right? One is to enable video production facilities to move from SDI to IP. And that's essentially where we collaborate extremely closely with our partners like Grass Valley. Now, the components of this solution comprises of the network built using Nexus 9000 switches, and a network controller, that's DCNM, that has a media controller functionality built into it. And I'll quickly share with you, what exactly we're doing for our customers. And then for our post-production workflows, we have an entire data center that you can build, again, using the exact same hardware, which is the Nexus 9K, and bring in virtualized media assets, right? So the assets could be running as containers, virtual machines, but net, it's the same architecture that you can follow both in studios as well as in data centers, powered by the same hardware. So Matt, if you can go to the next slide. Now, I know it sounds, if you look at the slides, it might look like, hey, yeah, I'm going to just migrate from SDI to IP. It's going to be as easy as that. But in reality, there are a few considerations that you would need to make, right? Let's assume you are tasked to run and operate a facility that's going to be running IP for production. So what are the things that you as an operator need to keep in mind? And that's exactly what Grass Valley and Cisco did when we were coming up with the solution is, in theory, networks have been carrying multicast traffic for 20 years now. And we've been doing PTP for timing for several years. So that essentially checkbox the requirement that, I need to transport video and audio over IP. But that's essentially where we had to really look at it as a holistic solution, right? Because it was not as easy as that. Now, what was unique about the move to IP for video production was that, one, we're carrying uncompressed video, and each flow could be 3 gig or 10 gig or beyond. So it's really, really high bandwidth flows. And two, you would have to ensure that these networks can guarantee end-to-end bandwidth availability and reliability, right? Because often I'm watching, a live sporting event, and I would hate it if the screen goes blank, right? So how do you design a network or an architecture that offers zero packet loss? So that was our first challenge. And the second challenge is that, security, right? And this is some of the things which I'm surprised. Maybe a lot of operators out there or customers out there who are deploying fabrics, they may not realize the importance of network security, but that's something that very early on Cisco and Grass Valley realized is that when it came to the SDI world, it's just a crossbar matrix, right? But in the IP world, you could hack. You can easily connect an unauthorized endpoint. Nothing is stopping me from taking my laptop and trying to subscribe to multicast traffic on the network, right? It's as simple as that. So how do you ensure that you have, not just reliable network, but secure this entire infrastructure? So that was the second challenge we had to solve. And third, of course, with 2110, you have to make sure that all your sources are synchronized, all your destinations are synchronized. So, that was another challenge, right? So how do I leverage, a feature on the network that can distribute not only multicast signals, but also timing? And last but not the least, right? Remember, this is a massive, technology change for our customers, right? Who are very, very comfortable leveraging an SDI-based solution, for several years. And it is important for companies like Cisco and Grass Valley to make this transition as smooth as possible and to hide any operational complexity there is, through software. And essentially, that is exactly what we went on to do when we came up with this joint solution, right? So Matt, as you go to the next slide, let's talk about how we addressed each of these challenges. So the first challenge was all about, hey, how do I reliably route uncompressed video over the network? Now, again, without going into details, right? Network, or IP network by default, when they have, multiple paths to go from the source to the destination, ends up choosing a random path. And while this works for your traditional IT-based deployments, right, like your TCP/IP workflows, for uncompressed video, this could potentially end up routing more traffic on a path than that path's capacity. So that could oversubscribe the path. So what Cisco did is we came up with a solution called non-blocking multicast. And non-blocking multicast, what it simply did is it added bandwidth awareness to protocols such as PIM and OSPF. Again, right? So with non-blocking multicast, we solved that requirement of ensuring that all sources, as the operator routes a source to a destination, that happens with end-to-end bandwidth guarantee. So that's how we address the first challenge. So Matt, if you go to the next slide. And the beauty about NBM or non-blocking multicast is that you can enable this feature within the facility, but it can also be used, as you transport media between facilities, right? For example, let's say you're doing remote production or you're doing centralized production, so where you have remote, studios. So you can extend this bandwidth awareness, across facilities as well. So that's the beauty about IP is it gives you this flexibility, and yet with NBM you get that reliable transport of video flows. Go to the next slide, Matt. So that, we quickly address the whole concept of secure, reliably routing flows. The second point, which is again extremely important for you to consider, is security. So what we've done with our solution is we've come up with this policy model, right, wherein you, the operator, decide, okay, what are the list of authorized endpoints? Now, for a given source, what multicast, multicast address it can use to transport the signals or to send the traffic, and for a given destination or receiver, what sources that receiver is authorized to join, right? And all of these policies are enforced on the network itself, but it can be pushed through GV orbit. And that's essentially how we've simplified the operations, right? So you don't necessarily have to define these policies, on the network, but you can define all of your policies on the orbit, and that we handle between the interaction that's happening between GV orbit and the network. These policies get enforced, and thus ensuring that the entire network is secure. Go to the next slide, Matt. And then the other challenge when it came to timing, right? So remember, the only way to build a scalable infrastructure is to go with a distributed model where you essentially distribute tasks amongst all the components, right? For example, in the case of an IP network, it's the IP switches to transport timing. Because this, in my opinion, was, at least when we started our implementation in 2017, was the most challenging aspect of building a facility, was to get this PTP right? And as a result of implementing this and working over these years, what we've found is that by enabling boundary clock functionality on the Nexus 9K switches, what happens is that the Nexus 9K locks to the PTP, grandmaster, and then it becomes a source of time and distributes timing to, in a hierarchical fashion, right? So that way you meet the requirement of ensuring that all your endpoints are synchronized, and then you can do this, irrespective of the scale at which you're building your facility, right? Like Matt was saying, you could build a small facility, medium, or large, but this exact same model applies to, all models. So that's again, a challenge that we pretty much solve by ensuring that we have a scalable way of distributing timing. Go to the next slide, Matt. And then simplifying troubleshooting, right? The reality is that you have this network. I remember when I was talking to customers very early on, right? The first comment that I got, was that, hey, SDI, I knew, right? I had my signal coming in on this SDI cable, going out of this cable, but IP, given that it's bidirectional cables, how do I trace where are my signals going? So Matt, as you start building out the slide, what we've done through software and hardware telemetry on the Cisco side, we have the ability to discover the endpoints, right? For example, when you plug that video switcher, you plug an audio console or a multi-viewer, they start showing up in our GUI. So it gives an operator not just visualization of how the network is configured, but it gives the operator complete visibility to where these endpoints are being connected, right? So that's one thing. And it not just stops there, right? So as the operator routes a source to a destination or multiple destinations, through software telemetry, the IP network informs DCNM as to, hey, how exactly were these flows routed? DCNM gets this information from each switch and builds a nice end-to-end flow path visualization. So now we've addressed that challenge of providing end-to-end per flow, flow path visibility on an IP network. And it also provides statistics, right, like the bit rate on a per flow basis. So you know what that 2110 video flow, what is the bit rate coming out of the IP camera as an example. And again, through telemetry, we've also have the ability to monitor how well is PTP working, right? So when you enable the boundary clock functionality, right, you have to make sure that all clocks are within plus or minus 500 nanoseconds of each other. And what PTP telemetry intelligently tracks is if there is a drift, right? For example, for any reason, if the offset goes beyond a microsecond or so, a notification is sent to the operator saying that, hey, look, something's going on with PTP, right? So enabling all of this real time through intelligent mechanisms like telemetry is just going to make sure that the operator can operate this network easily and ensure that they're proactively informed if something were to go wrong. Go to the next slide, Matt. And last but not the least, right? We've done all of this innovation to not only reliably transport the signal, but also provide ways in which you can operate the entire network. So we want to further simplify the end user operation by ensuring that the end user can just go to GV orbit to do everything, right? So what this means is that, remember, we were talking about defining those security policies and also getting notification back, getting an acknowledgement or a tally saying that, hey, yeah, this flow has been successfully stitched from this source to this destination and the flow path. All of that is seamlessly handled between the interaction that we've built through APIs, right? So essentially what is happening is GV Orbit calls APIs to push any policies, and we have AMQP-based notification that goes from the network back to the GV Orbit. So net-net, GV Orbit thus becomes a single pane of glass through which you get complete visibility, right from the source to the destination and the network in between. And this is where I would want to pass off the rest of the presentation to Matt to just show you how this view looks on GV Orbit. So Matt.
Yeah, thanks, Rahul. So when we're looking at that topology of a system within GV Orbit, then we can see the discovered devices, automatically discovered devices, shown on the left-hand side of the screen. Any of those showing as a bold white color are not yet included in the topology. But as devices are dragged into the topology and then connected to the IP fabric, then they automatically push updates of the send and receive host policies to the IP fabric through DCNM, through the API that Rahul was talking about. Meaning that when we're running in this mode, any multicast streams or IGMP join requests being sent by the devices would be blocked by the connected switch until they've been included within the GV Orbit topology. So in this way, without any additional steps in the workflow, the engineering team can control which devices are able to transmit or receive flows and prevent any unauthorized devices from being connected to the network to either transmit or receive unwanted flows. And as we can see here, where the policies that are created by GV Orbit are displayed directly within the DCNM client and then pushed in turn through to the switches making up the IP network. The information about the connected and included devices is clearly shown to the engineering team directly through the GV Orbit control graphing database, which is used to represent the topology. And then once included in the topology, the devices are then automatically available to be selected as sources or destinations and able to be immediately controlled from within the system or exposed to an operator control panel or to a soft screen. So it means that operators of GV Orbit don't need to be aware of whether the underlying system contains baseband devices, IP connected devices, or in fact a mixture of the two. And they're able to simply control routes from a source to a destination. So in fact, although the system's far more powerful, to an operator, it can appear as though they're simply controlling a single hybrid router. So once a route is commanded, GV Orbit will then dynamically calculate the path between the source and the destination, through automatic pathfinding. So although this is simple for the operator workflow, it's important for the engineering team to understand the actual path taken. So in this way, it's possible to access the path view. The path view shows the path used between the source and any specified destination. So we can see the complete path taken using information gathered about the IP network, as well as other parts of the system. So in this example, the signal path passes through a Cisco leaf and spine network, as well as passing through some other physical devices. The complete path is shown with the information gathered from various elements. So as seen, the information related to flows passing through the Cisco leaf and spine network, they're gathered from Cisco via DCNM through an API, and they're presented in the same view as the information gathered from elsewhere without any need to move between different applications. So in this way, it's simple to determine which switches, which interfaces are in use by any device, but without having to specify details of the multicast or the IP interface addresses. So we can refer to the signal path as going from the camera to the vision mixer input, with the system taking care of the underlying details. But alternatively, when it is needed, we can also view the same information in a way which continues to dynamically update, but shows more detailed information, including the bandwidth, the tie line utilization rate. That same level of information that Rahul was saying directly is available from DCNM. We can display that information also here directly within the GVOrbit tool, showing the specific multicast addresses being used. Now, the examples in the previous few slides are related to the orchestration and control elements of the system. And these are really important elements, but they are only a part of the story. And GVOrbit is a single unified configuration, control, and monitoring package made up of various individually licensed software components. So they run as containers in the system. And it's possible for us to license all of the components, so configuration, control, and monitoring, or only to have a subset of these. And then we can manage the complexity inherently associated with this step change in flexibility required for these new workflows. So we can act as an agile, dynamic, overarching system, broadly encompassing three main tasks, which are dynamic infrastructure management, dynamic device management, and dynamic software processing. So we can either have GVOrbit as the complete top-level system, or it can operate under existing third-party broadcast control systems. And you can take a look at some of these elements to see a few of the key advantages. So we have single unified configuration, control, and monitoring. And this isn't just about looking nice. This is about with all the operational work surfaces having a common look and feel. But it means that there's no need to switch between different dedicated apps in order to get the full picture of what's going on, with a consolidation of data repositories. So all changes are instantly recognized and immediately effective network-wide. There's dynamic orchestration, WYSIWYG. What you see is what you get. So it means it's on-the-fly configuration in real time, ideal for fast repurposing of resources in a rapidly revolving production scenario. So there's no downtime for pushing new configurations to system controllers or updating source or destination names, adding or removing devices, refiguring control panels, for example. An extensive configuration toolset with fully automated setup of COTS IP switches available in some configurations, and zero-touch provisioning for new devices in almost all systems. Gets you close to SDI-like connectivity. So when we're plugging in new devices, in almost all systems, there is no need for any command line or any work being done on the switch at that time. It's plugging it in and then allowing it directly through the control tools. So it means that we start to get SDI-like connectivity, where it's possible to simply attach new devices into the network and start using them, but with the distribution advantages of IP. There's also automatic pathfinding. So this is for dynamic insertion of processing elements as they're needed. And a really good example of this is using GVOrbit together with another Grass Valley product called Audio Live. When Audio Live is connected to the system, GVOrbit uses it to automatically create new audio flows or new audio shuffles based on the requirements of the receiving device. So it means that operators no longer need to consider the capabilities for each device when they're making their routes. And it allows the system to use many different devices at the edge rather than having restrictions on which formats are supported. So for example, when using GVOrbit with Audio Live, you're able to easily route from a device that could be producing two 8-channel 211030 audio streams And you can get that to a device that's only capable of accepting one 16-channel 211030 audio stream. Or you could create a new shuffle of the audio, no matter whether the audio originates from one or from many individual streams. And if the same shuffled version of the audio is requested by multiple destinations, then GV-Orbit can intelligently route the same newly created stream many times, allowing an efficient use of resources and a convenient way of monitoring shuffled audio. There's comprehensive monitoring with a very powerful feature-rich toolset. So the same tools are used to create highly customized monitoring screens accessible on dedicated clients or through an HTML5 web interface, as well as being used, the same tool, to create and modify multi-viewer configurations. So we can easily create custom alarms, choose different graphical indicators, display stream thumbnails in a way designed for scalability. Operator screens can be created with the appropriate level of monitoring and control to allow some remedial action, making GV-Orbit perfect for monitoring by exception, meaning a status window or notification will only appear after receipt of a warning or an alarm. And finally, an extensive range of operational control panels. So we have a mixture of LED, LCD, switch buttons. There's a new 19-inch rack-mountable capacitive touch panel, as well as soft screen control, meaning that customers can really choose the control surfaces that best suit their operational workflows and requirements, whilst still being familiar to traditional baseband SDI workflows. So the systems we've been talking about here are well established, and they're used by many customers around the world. In fact, we now have more than 100 major IP deployments around the world. A few examples of systems which contain a mixture of Grass Valley and Cisco solutions can be seen here, with NBC Stanford and BBC Wales Central Square facilities, as well as 4 outside broadcast vehicles in use by Arena TV, the newly completed OB vehicle for all mobile video. And there are many other examples, such as in the outside broadcast market, companies like Tencent and Shanghai Media Group in China, Gravity Media, Gearhouse Broadcast, who are using Flypacks for Australian Open, the Dome UHD truck in Canada, and plenty of studio facilities such as Canal Plus in France, Telstra and Foxtel in Australia, the Ericsson Broadcast Centre, BBC Sports in the UK, TV Globo in Brazil, Rai Italia in Italy, and many others. So with that in mind, I'm now going to hand over to Roger Crothers from the BBC, who's going to tell you more about their experiences with the BBC Wales Central Square project. Roger.
Thank you, Matt. I'll just start sharing my video, my PowerPoint, sorry. Okay, right. Let me see that. Let's just get that zoomed up. There we go. Okay, so I'm going to try and distill down what was a 10-year project into 15 minutes, so you're going to have to bear with me. I'm going to move quite quickly through the slides. I understand the slides will be made available to you after the presentation, along with the video of the presentation as well. So my name is Roger Crothers. I'm Senior Head of Engineering and Operations for BBC Wales. I've been involved in this project since the very beginning. I'm going to give you a very brief overview just to set some context and to tell you a little bit about what our objectives were at the beginning. So just a little bit about what we do. I mean, we're the BBC. You probably all know what the BBC is, no matter where you are. And we're a microcosm of it. In other words, we do a little bit of every genre that the BBC does. We do radio, we do news, we do drama, factual programs. We've got quite significant post-production facilities and so on. And we've been based in our current building for, well, we had been based in our existing building for nearly 50 years. And what we wanted was to move all of this production capability into a brand new building. Now, at the time, the intention was that we had to replace it because it was an aging broadcast center. It was an SDI, SDI infrastructure, which meant we couldn't produce live HD content from the building. It was also an opportunity for us to co-locate with another broadcaster, a Welsh language broadcaster called S4C, who are now also funded by the same mechanism as the BBC is funded through the BBC through the license fee. We also had a large technology estate of other tech, not just kind of broadcast equipment, but also traditional IT servers, and we wanted to look at virtualizing that. We knew we needed to modernize our workflows and be more efficient and effective. We're publicly funded at the end of the day, and it's important for us to demonstrate value of money for the license fee payers. So of course, we wanted to modernize our workflows. We wanted to automate where we could, and so you'll see some examples in a minute where we've used automation in the building. We also looked at the design, the organizational design. We had a full organizational design exercise undertaken, which looked at the structures of the organization and made those fit for purpose. And as with all projects these days, somebody's expecting a financial savings, so I'll talk a little bit about that. But obviously the key thing, and the reason I'm here today, is to talk about the adoption of IP. So I'll probably only touch gently on some of the subjects, but more than happy to take emails or questions from you separately after this presentation, if you've got any. So just on Central Square. So Central Square is based in Cardiff in Wales. It's the BBC's newest broadcast centre. It was the first fully IP broadcast centre the BBC's ever built, and it's been built around simply 2110. Just a little bit of history. I mean, we started off almost 10 years ago when we were doing the feasibility for a new building, look at an SDI solution for this building. We didn't believe that, even though IP was kind of there, we sort of didn't believe that it was going to be ready for our timescales. Then over time, 2022-6 came about, got ratified. There was a few people rolling that out, and we thought, well, we could go 2022-6. If that doesn't work, we'll always roll back to, we'll have as a backstop an SDI solution. And so we built that into our procurement exercise. But then as time moved on, because of course these things sometimes take a long time, 2110 came about, was ratified, and then we made the decision quite late on. The BBC doesn't normally take risky decisions, but unfortunately, timing wasn't on our side. You know, we had to make a decision. We didn't want to build the last ever major SDI broadcast centre in the BBC, and so we did take the informed decision to go down the IP route. And I'm going to talk about some of the complexities, difficulties, objectives, and so on that we thought we encountered. So the building itself was about better collaboration, it improved adjacencies amongst all of the production teams, open plan working, higher density. I mean, this is 50% of the size of our existing building. And as I said earlier, an opportunity to modernize workflows, structures, and the technology. So I'm not going to go through all of these. This is for you to look at your leisure afterwards, but that's kind of the facilities we've got in there. Generally speaking, we have 3 large studios, reasonably large studios. We do news out of there, 13 bulletins a day, potentially, out of the new studios. And we also do general purpose programs making as well in the general purpose studio. As I said, I won't labor on that. So when we decided we want to go down the IP route, there was a couple of things that we wanted to consider. You know, did IP actually work within a live broadcast environment? There wasn't many people doing it. Did we really want to be the first and the one to suffer all of the pain, which we thought it would entail? Would it cost more? We anticipated it would. New tech usually does cost a bit more. What are the benefits? You know, can we demonstrate that and justify spending more money if we're not going to see any benefits straight away? Who else was using it? As I said, not many. We visited a lot of different broadcasters around the world. Some were had plans to go to IP but hadn't done anything. Some had done certain parts of their infrastructure and enabled those. Some had done 2022-6. We hadn't seen any 2110 implementations anywhere that we traveled in the world. So there was a bit of risk in it. And, you know, we did have a risk appetite. We knew that if we built SDI and we went 2022-6, would we be looking at an upgrade again in 5 years' time? And so that was one of the key things. Well, the other thing that we considered was, what about interoperability? Because the BBC doesn't buy from a single vendor. You know, we buy best of breed technology. If we like a particular vision mixer or sound desk, that's what we buy because it's got the functionality we want. The downside to that is, because you're buying from different vendors, they all have to speak to each other, and that interoperability testing hadn't necessarily been done in the marketplace. So we had quite an extensive exercise to do that. We looked at what was available today, so that, you know, what estimate would we have as in terms of native IP devices. Matt talked earlier about how the cost should reduce when you move to a fully IP enabled edge devices. We estimated about 60% of all devices would be IP enabled. We kind of achieved that, just about, and that was only because through our procurement exercises we demanded it from some suppliers, and it was part of the requirements for delivery, which I'll talk a little bit about in a second. So in terms of IP benefits, I mean, it mirrors some of the things that Matt said as well. Future proofing was the key thing. You know, we don't build these broadcast centers every couple of years. We were in the last one for 50. We need to be in this one. We need to make sure that it lasts. And therefore, we wanted it to be scalable, that we wanted to be able to, you know, if tomorrow somebody starts acquiring content and requires us to move 8K building, we want to be able to do that without having to rip out HD SDI or Ultra HD SDI routers. Format agnostic, well, we know we move mostly SDI around, but by having a format agnostic platform, of course, it enables us to, which IP gives us, it means that we can handle a variety of formats, whether it's 360 streaming or whatever, we can move anything around. I mentioned the timing. I put it down as a benefit. I mean, benefit in that we were able to make the move to IP, but you could say it's also a disbenefit because it put us in a more risky position than we would be if we just went down an SDI route. And cost, longer term, we assume that it's cheaper, certainly cheaper than buying SDI first, ripping it out in 5 years' time, and then putting IP in. So some of the risks, though, we knew security was going to be a big one. We tried to mitigate this by embedding an information security person. We're quite security conscious in the BBC, and we wanted to make sure that we designed security in from the ground up. And so therefore they were involved right at the network design stage to make sure that the way in which the network worked was secure and that there was less risk. Obviously with SDI, no one's really hacking SDI, but of course with an IP network, it's now using you know, protocols which are openly available and understood. And the benefit we get from having IP, of course, is not just that we're using IP into the latest tech, it also means that we can move stuff from our corporate LAN and we can move that between our broadcast infrastructure more easily. Reskilling we knew was a big thing, implementation we knew was a big thing, and there's a question mark about refresh cycles. I won't labor too much on there, I'm covering that in the lessons learned bit. So in the procurement, we did decide to go IP rather than SDI. We awarded the contract to Grass Valley, as you know, that's why I'm here. We didn't go for Orbit, though. I mean, the guys have spent quite a bit of time talking about Orbit. We went for GV Conversion, which was an earlier platform. And we do have some of the difficulties around, it doesn't have dynamic device discovery in the same way that Orbit does. And the orchestration isn't as advanced. But we still got it working. Obviously, we're working, we're broadcasting on an IP infrastructure every day. We use GV nodes to provide gateways so that where we do have legacy devices that only support SDI, we can move between SDI and IP. And as I said, we adopted SMPTE 2110. As part of our procurement, we did ask that vendors, one, supported 2110, also that they supported NMOS to ISO 4 and 4.5, and that was, most suppliers agreed to do that, and that got us to a position where we absolutely needed that in order to go live. We had a very extensive then period of testing where we had so we built a kind of staging system with our SI, and they were doing a lot of the interoperability testing for us in the early stages. The only one thing I'd say that is not IP in our network is in our infrastructure. Sorry, is play out. If we were doing it again today, I'm sure we would build it as IP. I mean, it is fed by IP by the IP core, so it does receive IP feeds, but it's actually sitting on a couple of SDI switches, and that was because you could say it was just covering ourselves if we had a major problem with IP. At least we could always run in isolation with our playout system. Okay, so in terms of the technology selection, I'm not going to speak too much about this. This is mostly in the public domain, so you're welcome to have a look at that. We use DB as our SI, and they did all of the integration for all of our studios, post-production suites, and so on. but you can read that at your leisure. Okay, so lessons learned. I mean, we were very careful with vendor selection. We spent a long time looking at capability, visiting reference sites, trying to understand how experienced vendors were, whether they had products shipping and available and working and demonstrable now. There was lots of vendors that we talked to at the time who talked about having products that they were shipping in Q3 2018 or 2019, whatever it was at the time. That was no good to us. We wanted proven products. That's why we made the decision we did. On the SI selection, really important that you choose an SI as well that is committed to IP and has some experience of deploying IP solutions. That was invaluable to us because we could draw on a lot of their expertise. However, be prepared to learn and to spend a lot of time skilling your own engineers up and involving them as much as possible in the actual procurement process. I mentioned interoperability earlier. Obviously, that was quite a considerable thing. It was helped to a large extent by our SI, but we obviously that took many months. And you know, if 2110 was in the maturity state that it is now, clearly we wouldn't have spent so long implementing it. Probably the biggest issue I've got, and the one that probably keeps me awake at night, is the training of the engineering team. I mean, we've gone from a situation where we've had engineers who had who were absolutely experts on the knew everything about SDI, and we've given them an IP infrastructure and expected them to be as competent in that. And it takes time. You know, some of them had very little exposure to IP. Some of them have picked it up very well, but it's not something that happens on its own. We spent quite considerable time planning, training, and trying to get people engaged and hands-on. I say down there, consider a staging test system. We've made a decision to buy a staging system. I mean, these systems, they do require patching in a way that the old SDI switches didn't. And because of that, it's for your own confidence. I mean, it's good to be able to test those things and make sure that you can make sure you understand what the implications of deploying the latest patches and firmware releases are. So it's obviously a much smaller system than the core, but it's invaluable in testing that. And also building plenty of time for testing. We had a very long testing period. We had testing by the SI. There was at the factory. We had multiple phases then of testing on delivery, and then we had quite significant end user testing throughout the whole duration of the project. It shouldn't go amiss, really. I mean, we're all in a global pandemic at the moment, and clearly that's something that's severely hampered our project. We saw a 2-month delay when that happened, and obviously, but we managed. We always kept the project going to some degree. Fortunately, our IP infrastructure was largely tested at that point, and so we managed to get that in live in July of 2020, and that's now been on air, and it is till this day. So next stages for us are things like, well, we've got fibre to the Principality Stadium. We want to trial some remote production from there so that we can take those fibre feeds and we can drive production output from a gallery based in Central Square. We're also looking at linking some of our other sites in Wales. We've got a large drama complex in Cardiff Bay in South Wales that also have quite heavy post-production technology there, and we're looking at whether or not simply 2110 might give us the ability to link those sites, maybe centralize some of the technology, but certainly benefit from the connectivity that IP offers us. And obviously in the future, we may well be, and this is the BBC as a whole, is looking at cloud-based solutions, things like storage, whether it be a private cloud internally in the BBC, I'd say that's almost certain. Things like transcode capability, which will mean that we don't, every time we build a new broadcast center, have to build transcode functionality into every site. So that's it in terms of my slides. I'm going to hand back, I think, now to Matt. Okay.
Yeah, so it's to Rahul.
Yeah.
Thanks.
Awesome. So thank you so much, Roger, for sharing your success with at BBC Wales. So very quickly, right? At this point, we probably have time to just quickly summarize everything that we've discussed, and that's essentially what I'm going to do. So what is Cisco and Grass Valley working on next, right? So for our customers who've already invested in the Nexus 9K, again, FX2 models, or for the ones who are looking to invest in the Nexus 9K, there are several features within the ASIC, and one of that is the ability to do multicast NAT. So we ship this feature on the Nexus 9K, and use cases include the ability to ingest content. Say you have a OB truck that's doing 2110, you want to get feed back to your facility, and there's an address overlap, you want to do NATing, or you want to hand off content to third party. You can do egress NATing or even destination control for that example. So we're working with Grass Valley to integrate these workflows within Orbit itself. So that, again, right, taking the benefits or the features and making it simple for our end customer to use it. So that's what we're working on. And then, of course, advanced media flow monitoring. Our switches can do deep packet inspection. So, if there's any kind of loss at the service provider, say doing remote production, we can detect that and again feed this information back to Orbit. So again, to give you a single view as to what's going on end to end, right? So with that, I just want to highlight that between Grass Valley and Cisco, we just bring in the best of both worlds, right? Now with Cisco, we have all the experts needed to build a reliable network, scalable network. And similarly, in Grass Valley, we have experts who can build, broadcast equipment and IP-based broadcast equipment. And essentially, what we're doing together is we've invested in labs. We have a lab both at Cisco as well as in Grass Valley with each other's equipment. So every time we have a software release, we ensure that we validate it internally before we hand it off to our customers. And then, just to make sure that both companies are making progress, we are addressing customer needs. We do have a bi-weekly sync up between the product teams, that's myself and my counterpart in Grass Valley, just to make sure that the end customer or the system integrator can benefit from the work that we're doing right between Grass Valley and Cisco. And we've had a lot of successful implementations. I did see a few questions come up from the audience saying that, hey, is IP really mature? It's still considered, bit of a risk. But I just want to reiterate the fact that we've had several both small, medium, large deployments across OB trucks, across studios, remote production. And I am confident, at this stage that both Cisco and GV have a solution that you can deploy and go live. So with that, Katie, I want to hand it off to you. I know we are at the top of the hour, so you can just conclude and close the session.
Great. Thank you, Rahul. And thank you to all our attendees for joining today. As a reminder, you are going to get an email with a link to both this recording and the presentation later this week. And then also, as you close out of your browser, you're going to have a few survey questions. If you'll give us your time and fill in the survey questions, that would be great. We always appreciate your feedback. And with that, we hope you have a great rest of your day.